Alright, welcome. This is going to be my layout sketch design walkthrough. I'm going to be illustrating how to do a specific type of layout sketch. The type that I believe we should run in our build season. And I'm going to do it through an example, a robot archetype that I thought up earlier today. For context, what you should have going into your layout sketch designing is most of the concepts of your design already planned out. This is a very good example of how planned out your design should be going into a layout sketch designing process. So, you have basically the layout of your wheels. You have some basic positions of where your robot needs to be and where some parts of your robot need to be to score and or intake. And you have some design constraints as well already thought of. So let's go through the components. The end effector, which is slightly drawn, it's using left-right wheels. What this means there's not top and bottom rollers. These little rectangles right here are wheels. So they're basically horizontal wheels. I called them left-right wheels because it's a little bit easier to picture in your head that the coral is having wheels on its left and its right instead of its top and its bottom. The big part about this end effector design is it's using a centering flap for mechanical autoline scoring. And the Robocharger's design is really where most of the inspiration for this mechanical alignment scoring came in. This was their end effector system, and what they would do is they would use this flap to mechanically align two reef branches by ramming this into it and score efficiently that way. So, and as you can see with my design, it is incredibly similar. It has another very similar version of mechanical reef aligning, but there are of course some differences which I'll explain as I go on explaining this. It will score bumper to reef, so it's better for drivers. We can ensure that the angle of our robot is the same on scoring every time if we just ram into the reef. And one of the main parts of this design, which I did not sketch, is this whole system is going to be on a pivot which can rotate out and over the front bumper and act as a ground intake when needed. So, that's the end effector explained. The hopper, it's the same angle as the reef branches. It's as low to the ground as possible so that you can shoot you can chuck coral into the robot while it's maybe even a foot away from the coral station. And it's indexing coral with a series of compliant wheels. Something that I very much wanted to design, at least, is a 2847 style algae intake and shooter.
Starting zone and scoring in that autonomous grid. Now we're into teleop. Drivers have taken control. Oh, very close match, all tied up at 50 apiece. A lot of scoring going on. Blue Alliance just delivered not one but two to their processor, and the Red Alliance human player gets those
shooting it and tossing it into the net. I think this style of algae intake is incredibly awesome in my non-expert opinion, and I would really love to build it myself. So this is the mechanism I'm very interested in designing, and I did plan on having a different form of algae scoring that would have been attached to the elevator, but I chose to opt for this other option because of two main reasons. One, I want to make sure that if the end effector wheel motor is broken, this robot can still do something else in a match other than climb and play defense. And two, I really want to design this, and I think it's going to be fun. Then I had a simple idea for a climber. I want to do a Rest Town style climber and do it right this time. And for my idea, I didn't entirely sketch it out here, but for my idea, you basically have one half of a triangle on your climber here, and what that allows is for the cage, for the first pull of the cage to always center in. What this triangle does in terms of manually aligning is it allows you to ram into the cage and not care about whether the cage is going in this position. So those 4 circles would be the 4 bars of the cage, and in that position you can actually have issues where you don't climb correctly, so this kind of solves that problem. And I think it would be way better for manually aligning than the solution that I tried to cook up in season. So that is basically my whole design that I've sketched out already, and now I'm going to be tracing it out in a layout sketch form, and then going at least into a little bit of detail on all of the mechanisms themselves individually. Alright, so when thinking what to do first here, there's really multiple things you can do. What I want to do is going to be a little bit out of the ordinary. It's actually going to be creating a new part studio and call it Spacing Simulator. What I'm doing here is I'm just using this part studio to sketch out specifically where I might want my wheels to be. What diameter wheels in particular, I like 4-inch diameter wheels because they have the widest area you can get for compliant wheels. And what I'm going to do here is I'm going to model 2 wheels, and I'm going to use some constraints to make sure that they are in the same position on the x-axis of the coral. So now I can move them around, and they're going to be at the same position. Now with more constraints, I can make them fully constrained. So now they're always going to be at the same place relative to the coral. Now what I'm going to do is I'm going to do a simple radius line from inside the coral, and I'm going to mirror the 2 wheels. And now I have exactly what I want. I want to be able to play around with the wheel spacing to see how far they come in contact. That looks good to me. So now I have the basic layout of how I want my wheels. And the most important thing that I got from that is this dimension right here, which is how far apart they are vertically. This is actually the only dimension I'm going to use in my other sketch over here. So I'm going to go in here. I'm going to first draw a little rectangle. Now what I'm going to do is make this 1 inch and mirror another rectangle here. And I can make that spacing exactly what it was in the other sketch. And now I have my perfect little pair of wheels here. They're not at the right angle yet, but I haven't really drawn a single thing. So now I'm going to work on that. But what I will be doing is drawing in a model of the source. So I'm going to go to 2025 game manual, the sloped 55-degree tunnel. Okay, that's all that I really need to know from that. So I'm going to go back to the side layout, and I'm going to draw this, just a nice little parallelogram here. This, I believe it said, is 55 degrees. And this dimension was 95 centimeters. I forgot what it was in feet. Actually, I think I remember. It was 3 feet plus 1.5 inches. So 37.5 inches. Perfect. So you see, as I'm sketching these things, they're not getting fully defined immediately because I'm adding sketch geometry as I go. The process of making a layout sketch involves a lot of doing things on the fly. So, I mean, that's just really what you have to go for. So, because I'm doing this video, I'm going to act like I don't know the angle that you need for the reef branches. So I'm going to go back to the game manual, I'm going to select reef, and I'm going to see, I'm going to do some reading, look at L1, 2, 3, I'm going to keep going, and I'm going to see that L2 and L3 are angled at 35 degrees. And that is what we want the base angle of our intake and end effector to be. This is because if our pivot breaks, the majority of the levels of the reef we are still going to be able to fill. And now I can go ahead and start adding a little bit more geometry. So these wheels obviously have to start within frame perimeter, and for the sake of this, I'm going to make sure that I know exactly where frame perimeter is by just extending this line. I personally would like them to be as close as possible, so for the time being I'm actually going to dimension this to be 1/4 inch away. And I'm going to pull this dimension off to the side so I can very easily find it and know in the future if I might want to change it. Currently, we have this system. We have a intake, basically, that's taking in coral. This is the flat surface of that. Oops. I don't know how I did that. 3/8. And yeah, to make it as low as possible, we can run our wheels all the way down into here because our chassis here actually begins like that. So we can go all the way down even to like here. We have the position of the wheels for the end effector and the line, which is pronouncing the bottom face of our intake. We can figure out how far we will be able to have our coral go from the source into the robot. So we're basically figuring out how good a job we have done. And now we get that we can be about 9 inches away from the coral station and still intake a coral. Okay, so now what you might want to do is move on to another mechanism. Actually, this sketch probably is not complete because these wheels have a pivoting form which we haven't touched on yet. So this point of the wheels hard stopping on the frame rail bar might not actually be the best because we actually want these wheels to be able to pivot out over our bumper and work as a ground intake. So for now I'm going to sketch basically its second position, and doing position oriented sketches is something that is incredibly important in layout sketch designing. And what I mean by that will be pretty clear in just a little bit. Now, what we are going to do is make a pivot point. And what we want is for the pivot point to be inside of the robot, and for these two positions to be in a nice place. This is where layout sketch work becomes a bit hard, because now you have a bunch of things which are moving around because none of the geometry has been decided at this point, and you need to figure out which one you want to be where and how it's going to affect the rest of your design. So, first things first, this pivot point needs to be inside of frame perimeter. So what I'm going to do first is I'm going to figure out what's the minimum distance I can get it inside frame perimeter for it to work. Now I can copy this dimension, and I know that this right here is the radius of a bearing with a 1/4 inch of material on it. And that's the minimum amount of material I'd want holding in a bearing. So that's exactly, the radius of this is exactly what we're going to put in as our distance from here to here, making this the minimum distance for a bearing. And I went ahead and copied that distance, and there it is. So as you can see, now that we have these dimensions, you can start to understand the relationship between the different geometry. Like, I can move this around, and it's basically just moving the pivot point up and down. And if I slide this up and down, it's also moving it, the pivot point up and down. So the relationship of these two is going to determine how high the pivot point can be. So what this means is I can constrain this to the minimum position I'd want it to be again, and constrain this to the minimum position I'd want it to be. And now we have something like this. And now what we can do is move our favorite coral end effector around. The position of this end effector on the pivot in its starting configuration is affecting the position that the robot can be away from this coral source intaking. For now, I'm going to set this to the minimum thing that I want, which is for it to be a coral width away plus a bit of tolerance. I'm just going to keep using a 1/4 inch because it's served us well so far. And this is actually a dimension that I might forget, so I'm going to go ahead and put it in a variable. I'm going to call it source robot dis. And there it is. So now what we're going to do is we're going to make sure that these wheels in this location, this far inside of the robot, are able to score effectively on the reef. Front edge of the trough is 1 foot 6 inches from the carpet. So this is going to be our first constraint. We're going to make a rectangle from here to here. All of the reef parts I'm going to make not construction because I don't want to get the parts of the intake that are in here confused. I think that I'm understanding it enough for it to be correct. But as a general guideline, there is pretty much always going to be public available CAD for the field each year. It just takes forever to look through, so I'm just going to use the game manual instead. Here we go. We have our reef faces, or branches, I should call them. So what I'm going to do from here is I'm going to select all of this, Control C and then a Control V, and everything is probably going to be, oh, never mind, everything is going to be just fine. Hey, look, it's all good. Okay, so this is now vertical and parallel. So now what I'm going to do is I'm going to draw in a coral. Now we have a coral that we can go ahead and score on a reef branch. Let's go ahead and pause this. Source robot distance. I'm going to go ahead and mate this coral to this for now. Yeah, never mind. Where it was before was probably okay. I'm gonna do that for now. So this basically is a coral on the reef face in the wheels as much as it is. I think I'm going to go ahead and do this again for L4. Wait a minute. It seems that I've skipped over a little something here because I don't actually know if this pivoting for the ground pickup is going to clip into our bumpers. So I'm going to go ahead and click the check mark for a second so that all progress is saved, and then go back in and make sure that I've done a good job. So to do this, I'm going to make an arc, and then I'm going to make a slot. I'm going to make this point right here, for real this time. Now I'm going to put this right here, and we are going to see that the wheels will not come into contact with the bumpers. If you wanted to see this further, you actually could because of how copying works. Copying is so lovely, it doesn't actually make any sense sometimes. I'm just going to go ahead and put this here, and I'm going to make a little line from here to here. I'm going to make it tangent to the arc. Then I'm going to make a line from here to here. So now I'm going to make a line from here to here. A line from here to here. And I'm going to make this equal. Okay. Here we go. Now we have a version of our beautiful intake that we can manipulate around our pivot point. Sorry that took so long. Layout sketches are sometimes confusing. So basically what I've gone and done is I mapped out the start location, the end location. I made this lovely pivot point with geometrical factors that I intend to use. Then what I've gone and done is made an arc and a slot around my range of motion, ensuring that I will have a design that's able to go through without causing any interferences. So this first part of the layout is done. That took way longer than I thought it would. How long is this recording? 48 minutes. It's hard. Building a robot's hard. Anyways, now what we've gone and done is a pretty good thing. And now that we have this lovely reef sketch, I'm going to go ahead and design the other mechanism, which is going to be in this view, which is the algae manipulator. Here we go. I'm just going to make a floating pivot point in space, and I'm going to make a floating pair of wheels. Let's call these 3-inch wheels. Now I'm going to sketch in an algae, or I think it is. I believe that they're 16 inches. I should probably check. So I'm going to go back to my table of contents, go to algae. Each algae is 16.25 inches. Okay. It's a simple dimension change. Oops. Not 26.25. Here we go. And I believe that they rest. I don't quite know how they rest. I actually would like to see. Actually, I bet I can look on the field CAD. We're gonna do center distance. X is 6 inches back and 51.575 inches up. So here we go. We have 2 wheels, which are going to be used to get algae. And basically, what we need to do is to have this mechanism work, right? To have it pick up algae off of the 3 positions, the top, the floor, and the middle algae. They can't be at the same X position away from the coral source with a single pivot. And that is 100% okay. But for the sake of designing, I want to make sure that the distance away from the top one is the same thing as the distance away for ground intaking. Okay. So here we go. This geometry is already a little wonky to figure out. Oh no. Oh good lord. Anyways, I'm gonna do some blank constraints so that I can move this around for the time being. So what I'm gonna do here is I was about to model this off of a random dimension based on just how far I wanted this to be able to take it in, but instead I'm going to model it off of compression, which is a lot surer way of doing things. So basically what I've done is I've just put an algae inside of this intake. So it has the position inside the reef and the position inside of the intake at the top. And what I want from this is I want a certain amount of compression. So the distance from this wheel to this wheel, I want to be 16.25, the diameter of the algae, minus a certain amount of compression. Which I will have found through prototyping. So now we have the top basically mostly modeled. If you move this pivot point around, it's still there. And if you change the orientation of the wheels, it still is modeled in the same spot pretty much, with the same compression in mind. So now that that's settled, we can work on the ground algae. And the big thing is making sure that it's over the reach of the bumpers. And to do that, now we're going to adjust the location of the pivot. We're going to move it out. We can add a dimension for now between here and here. And this pivot point can still move around. It's still not fully constrained. And this basically means that we have a lot of flexibility in our robot of where this pivot point can be. Life is Roblox. Anyways, what I'm going to do now, oops, I don't want to make this tangent anything. What I'm going to do now is make this horizontal and sketch out a third. So here we're at a bit of a halt. We don't have our sketch defined, and defining it based on nonsense isn't really a good idea. So for now, we're actually going to leave this and figure out the situation of our elevator, because that's going to affect where we want this pivot point, because we probably want it out of the way of the elevator, but we also might be able to move the elevator out of the way of the pivot. This currently doesn't have a position inside of frame perimeter, so we are going to go ahead and help it out. We're going to make a fourth position, and it's just going to be one that's inside frame perimeter. That is our beautiful mechanism that is not defined in any way. And because we've separated that from the rest of our geometry from before, this is so much less complicated than it would have been if we added it to all of this nonsense as well. Okay, I'm back. So at this point in our design, we pretty much need to get a place for the elevator. Now, this mechanism, I think, will need to be on the side of the elevator. So the elevator will probably need to be to one side of the robot, and not the other. So it seriously does not matter where the elevator is for this design. It could be back behind the wheels or it could be in front of the wheels. It would be able to pass through in either case. It's really just how connected of a system do we want, and really it's where do we want the climber. So I'm going to go back to the side layout, and since this is our frame rail, I'm going to start it on the inside of the frame rail. So we'll need a 3-stage elevator. I already know this just because that's what literally everyone needs. Actually, we might not. Let's see, how much extension is this from this point to this point? We need whatever that is in extension. Let me try go here and do some MKCAD. Here we go. Okay, there we go. We have our beautiful elevator. It's as tall as it needs to be. The top of this from bottom is 43.75 inches. I want to find starting configuration. Starting configuration max size. May not have a robot perimeter greater than blah blah blah. Be more than 3 feet 6 inches tall. So 3 feet 6 inches. So 3 times 12 plus 6. That's 42 inches. So this is too tall. It's too tall by 2 inches, so making this 3 inches should make it not too tall. 42.75. So still too tall, but that's okay, because now we can go ahead and change it. Is within starting. So this is perfect. This really is kind of the fastest way to make an elevator. We have our elevator that fits the starting configuration, and now I can just copy these lengths. 38 inches. Here we go. That's the carriage. This is the beautiful elevator. Side view. Perfect. And like I said, it can really be anywhere. All of our things can really be anywhere. They can all change. This is not in starting height at all. So I think it's time to fix that. 42 inches. So I'm going to look at the reference material a bit. So it looks like they curve it all the way into their robot, which I didn't expect, but that looks like a good way to get this to fit in. Okay, I just realized that I haven't talked in a while, but basically what I'm doing is I'm making some of the positions different so that this can fit inside frame perimeter nicely. And it all works now. Oh. Looks like this might be our final dimension. So let's just put this wheel inside the robot now. Maybe instead let's control it with this. We want to be able to have a 6-inch sprocket. This thing might be heavy, so having a sprocket that's able to be up to 6 inches, pretty good. So there we go. That's the algae layout fully constrained. Now, I believe we can constrain our layout here, because this is 5.5 inches. You can go back here and just make this 6 inches. So, right here at this point in time, we basically have the entire layout done, which some people might be a little bit confused because we haven't sketched the climber yet at all, or the front face of the elevator. And one of those things does need to be done, and that's the front face of the elevator. I forgot that a little bit. We have our 2 outside elevator pieces, and we know how tall they are from here. So we can actually use features of other sketches and other planes. Okay, so there we go, that's the elevator all done. There's 1/2 inch between the bars for the slider bearing blocks. And yeah, that's the basic layout. As you can see, we can, oh, whoopsie daisy, hang on. As you can see, I forgot to use dimensions correctly. As you can see, we can move this side to side because we don't actually know how wide we want our elevator to be yet. And these dimensions are entirely accurate to what we've done in Crayon CAD. So, yeah. We can even do the carriage, which I forgot to do earlier. So now we can actually head back over to our spacing simulator and see pretty much exactly how wide we need the inside of our elevator to be. So it needs to be bigger than 10.75 inches, so it can be 11.25 inches. I like the sound of 11.25, so I think that's what I'm going to use. 11.25 inches. There we go. So now I'm going to assume that the room we need for our algae mech is some space to the right. And because of this, I'm actually going to go ahead and do this at 1/4 inch here. So now what we can actually do is we can go ahead and move the frame rails to reflect this new situation. So the distance here is 2 inches. We want to make that a 1/4 inch plus 1.75. And there we go. that should now reflect our new lovely placement for our elevator. Anyways, to make this elevator position reflects the position it has in the robot, I'm actually going to do a plane point on this point, and I'm going to move it above this elevator layout, and then just remove the front plane and click this plane instead, and all it does is move the sketch to the position where the elevator is. This has almost all the information you need to divide up your mechanisms and start work on the actual robot. It's so close, we just have not done the climber yet. Have it ram in here. So, we have 16.5 inches here. I'm going to make a sketch on the right plane. This is going to be the climber layout. First thing I'm going to do is make a midpoint for the room. So I assume that the climber should be a little bit closer to this side. So I'm just going to make a little line where I think the climber should be. I'm going to keep that other thing as a reference. I think it should be like here, roughly, like 2.5 inches to the left of the midpoint. I think I'm thinking a little bit too hard about this when in reality I haven't even done the right sketch. So I'm going to go over here on the front plane. The climber should basically be right here. I'm going to do a 1/4 inch plate, which is going to be the centering guide. It's just going to be like an 1/8 away from this, and it's 1/4 inch thick. So this is going to be 2 inches, and this is where I'm going to have the cage pipes. Here's roughly how far out you want your gusset to be, like 6 inches, that should be good enough. Here's your vertical position. Now here is going to be your horizontal position. Now you can draw your cage. I don't know how to draw it, so I'm again going to go back to the game manual. Okay, so here we go. We have the cage. Here it is. It's on the guy. And then it goes into the robot here. For the pivot points, I'm going to do the circle triangle method, and I'm just going to figure out where this can be in the robot. Oops. Again, for the dimensions that I want to care about or don't want to care about, any dimensions I want to keep separate, I just move them off to the side. So this looks pretty good. This climber will always stay up here for the majority of the match, then it can go down, then it can go all the way in. Looks perfect. That's all the geometry you need in this document. So anyways, this is the main robot layout. Next steps are going through each mechanism and defining it further with more layout sketches so that you can create a layout assembly with moving geometry.